welcome geometry to our first lesson of chapter 7, all about polygons. There are 4 questions for your do now at the very top. Take a minute to pause the video, try those out. See if you remember how to name these. We went over it a long time ago, I know, so just refresh your memory a little bit. What do you call a polygon that has 4 sides, 6 sides, 25 sides, and 9 sides? So 4 sides is always a quadrilateral. We have special quadrilaterals, which we're going to talk about, but if it has 4 sides and that's all you know, it's always called a quadrilateral. 6 sides is a hexagon. 25 sides is a 25gon, and then 9 sides is a nonagon, which is always kind of fun to say. A little bit of a tongue twister there. So polygons in general. A polygon is on a plane. All right, it's a flat surface. A plane figure formed by 3 or more closed segments called sides. We know that if we have, for example, 3 segments and they are not closed, that would not be a polygon. So they all need to touch. So this one would have to extend up there, and we would have a triangle. A diagonal is a segment that connects two non-adjacent sides. All right, 2 non-adjacent sides. So I am going to connect A and C with a diagonal, which is my little hashy dotted line there. The sum of the interior angle measures the sum of the measures of the interior angles for any convex polygon. Remember, we have some that are concave. So for example, this would be a concave pentagon. That would not work for this. It would have to be convex. So everything points out. So the interior angles for any convex polygon, n number of sides, is given by a formula. So we have 180 times n minus 2. That is going to equal the sum of the angles. So this little weird looking e just is called summa. It's a Greek letter, summa, and it stands for sum in math. So if it helps you to just write sum of angles instead, that's fine. So down here we have a triangle. Triangles have 3 sides. The sum of the interior angles for a triangle would then be 180, 3 minus 2. Well, 3 minus 2 is really 1. So 180 times 1 is 180. For our next one, we have a quadrilateral, and you can see I've drawn in a diagonal there. Quadrilaterals have 4 sides. So the sum of the interior angles for a quadrilateral would be 180, 4 minus 2. Well, 4 minus 2 is 2. 180 times 2 is 360. You'll also notice that if we look at our diagonal, we've divided this quadrilateral into 2 triangles. Well, if each triangle is 180 degrees total for its measures, it makes sense that 2 triangles would be 260, or 360, excuse me. Pentagon is our next one. It has 5 sides. So we would take 180, 5 minus 2. So that would be 180 times 3, which equals 540. Again, our diagonals here break up our pentagon into 3 triangles. So 540 makes sense. Hexagons have 6 sides. So we have 180, 6 minus 2, which is really 4. And 180 times 4 is 720. So every convex hexagon has a total angle sum for its interior angles of 720. So now that we've learned about the interior angles of polygons, let's take those and apply them to some real shapes. So let's say we have a decagon and we want to find the sum of the interior angles. Deca stands for 10. It's got a 10-sided figure that is convex. So we would have 180 times 10 minus 2. Well, 180 times 8 is going to be equal to 180 times 8 is 1,440 degrees. Let's do number 2 together. So we've got a 15 gone. So we would have 180 times 15 minus 2. So that's 180 times 13. 180 times 13 is 2,340 degrees. All right, I'm going to skip 3 and 4 for you to try in just a moment. Let's look at 5 and 6. So for number 5, we have 1,980 degrees. That is our angle sum, right, for the interior angles. And we know it has to equal 180 times n minus 2. There are a couple different ways to solve this using algebra. I do not have a preference for which way you solve it. Personally, for me, the easiest way is to divide both sides by 180. That gets us 11. 180 divided by 180 is gone, n minus 2 is left over. So I know that 11 equals n minus 2, so if I add 2 to both sides, I find out that n is equal to 13. I find that to be the easiest way. If you would like to use another way, and you got 13, great. For number 6, we have 2,080 is equal to 180 times n minus 2. I'm going to divide both sides by 180. So we end up with 16 equals n minus 2. I need to add 2 to both sides to get n by itself. So n is equal to 18. So this is an 18 gone. Anything over 12 that's a polygon, we just name with the number of sides. So remember, we stop at dodecagon. All right, I'm going to skip 7 and 8. 3, 4, 7, and 8 are for you to try, and I want to take a look at number 9. So for number 9, it says 5 angles of a hexagon measure 119, 129, 104, 139, and 95. Wait a second, it's a hexagon. Hexa means it's 6-sided. If it has 6 sides, it has to have 6 angles. Oh, it says right here, what is the measure of the 6th angle? So we are going to use, let's just go with x for our unknown 6th angle. Well, if it's a hexagon, then we know it has 6 sides. So we can take these, add them all up to make 180, and multiply that by 6 minus 2. $180 times 6 minus 2, which is really 4, is going to get us 720. When I add 119 plus 129 plus 104 plus 139 plus 95, I end up with 586 plus x is equal to 720. So I need to subtract 586 on both sides. That leaves me with x is equal to 134. So my unknown 6th angle is 134 degrees. All right, pause the video right here, and I want you to try number 3, 4, 7, 8, and 10. We're going to go over it in just a minute, so pause the video, try them for yourselves. So for number 3, for our 21 gone, you should have gotten 3,420, 3420. For our octagon, that's 8 sides. So you should have gotten 2,880. For number 7, with our 900 degrees, you should have gotten a 7-sided figure, or a heptagon, in case you're wondering, heptagon. And then for number 8, you should have gotten that there were 30 sides, or 30 angles for that one, a 30gon. For number 10, when we set them equal to 180 times 4 minus 2, because it's a quadrilateral, so it's got 4 sides, we end up with 247 plus x equals 360, so x is 113. Please email me if you have questions. All right, the sum of the exterior angles now. Sum of the exterior angles. These exterior angles are always supplementary. Right? Supplementary, that means they add to 180 to their adjacent interior angle. So in this case, for example, when we take a look at number 9 down here, I have an 89-degree angle here. Well, 89 plus what is equal to 180? My question mark must be 91 degrees. So I know that this angle right here is 91. Here's a cool, fun, interesting fact, though. Instead of having to find each of our angles and then find their adjacent supplementary angle that is exterior to the figure, the sum of the measures of the interior angles in any convex polygon, again, it must be convex, with n number of sides is always, 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 this is really important, always 360 degrees. Every time. Doesn't even matter. If you add all these together, it will equal 360 degrees. So, I'm going to prove it to you because some of you are, a little skeptical, and that's okay. We know we've got 91 degrees right here. For 71, we have to subtract that from 180, and we end up with a 109-degree angle. And then for our 124, this is, oops, wrong spot. This is a 56-degree angle. And then for our 76, that would be a 104-degree angle. So if I look at the exterior angles and add them all together, we would have 56 plus 91 plus 104 plus 109. If I add all of those up, you get, drum roll someone, 360 degrees. So for all of these, it should be very easy. What's the sum of this figure right here? Pause the video. The sum of the exterior angles is going to be 360 degrees. Isn't that awesome? The sum of the exterior angle measures. And again, this is for any polygon. A triangle, a quadrilateral, a dodecagon, any polygon. The sum of the exterior angles is 360. Super awesome, right? Try out the big ideas online skills practice. That is the end of our notes for today. We're going to continue 7.1 tomorrow. And we are continuing our 7.1 angles of polygons. Today we're going to talk about some special polygons. We're going to start with equilateral. Equilateral. An equilateral polygon has all sides are congruent. So in our leftmost picture here, where we have our 6 tick marks, this would be an equilateral hexagon. All right, equilateral. All the sides are congruent. The next one we're going to talk about is equiangular. All right, equiangular. In this one, all angles are congruent. So our middlemost picture here, we have an equiangular hexagon. Equiangular and equilateral. Our third special polygon is what we call regular. A regular polygon. For a regular polygon, both the angles and the sides are congruent. So our left or rightmost picture here, our rightmost picture is a regular hexagon. And this can be for any polygon, all right? It doesn't have to just be a hexagon. It could be a triangle, it could be a quadrilateral, which a regular quadrilateral we call a square. It could be an heptagon. It can be any polygon that is equilateral, equiangular, or regular. So let's try number 11 together. All right, let's try number 11 together. We want to solve for x. We want to solve for x. So that means I need to take all of my angles here. I know that all the angles will add up to be 180 times n minus 2. Well, how many angles do I have? 1, 2, 3, 4, 5, 6. So 180 times 6 minus 2, which is really 180 times 4, is 720. So now I need to add all my angles together. So I'm going to start here with 110 plus 8x minus 1 plus 5x minus 36 plus 116 plus 7x plus 19 plus 6x minus 2, and that is our last angle, and these will all add to make 720. I'm going to color code these so I can combine my like terms. So I have an x here, and here, and here, and here, which means I can take 110 minus 1 minus 36 plus 116 plus 19 minus 2. So when I do that, I end up with 26x plus 278 is equal to 720. I subtract 278 from both sides, and I have 26x is equal to 442. Divide both sides by 26, so x is equal to 17. So now I can plug 17 in for any of my x's and find out what that angle is exactly. We're going to skip 12 for now. I want you to practice that one. All right, practice that one. And we are going to jump down to number 13. 13 says, what is the measure of one interior angle of a regular pentagon? A regular pentagon. Regular means that we have all sides and angles are congruent. So a pentagon, penta means 5, so it's a 5-sided. So if I take 180 and I times it by 5 minus 2, I'm going to get 540. If it's regular and it's 5-sided, that means that each angle is going to be, pick your favorite variable. I'm going to stick with x. Each angle is x degrees. Well, how many angles are there? There are 5 of them. So that means I have 5x is equal to 540. So if I divide both sides by 5, that means each angle is equal to 108 degrees. We are going to skip number 14 and take a look at number 15 for just a minute. All right, we're going to take a look at number 15. If the exterior angle of a regular polygon measures 15 degrees, how many sides does that polygon have? Exterior angle. Remember, exterior angles add to 360 every time. Interior angles we know are 180 and minus 2. So in this case, it's going to add to make 360. So we know we're going to have 15 degrees some amount of times. We don't know how many. So 15 times x is going to equal 360. If it's regular, remember that means that all sides and angles are congruent. So each of those exterior angles is going to be some x degrees. So I need to divide both sides by 15, which means I get x is equal to 24. So this is a 24 gon. All right, it has 24 sides. Another way of saying it. All right, the last problem we're going to try together is number 17 down here. So 17 says the polygon is regular. Well, what shape is it? It's a pentagon, right? It's got 5. If it's regular, that means we have angles and sides are congruent. So I can make my tick marks on here because I know it. If you know it, mark it. I can also mark my angles. That means every single one of these angles is 9x minus 18. I also know that because it's a pentagon, and this is an interior angle, then we have 180 times n minus 2. Well, our n in this case is 5, so this is 180 times 5 minus 2, which is 540. Now, I don't really want to add 9x plus 8 minus 18 plus 9x minus 18 plus 9x minus 18 plus 9x minus 18. I'm really not interested in that. Let's figure out what just one of these angles is. They all have to be congruent, so that means if I take 540 and divide it by 5, that will get me what just one angle is, which should be 108. So each of these angles will equal 108 degrees, but I need to find x. So that means 108 must be equal to 9x minus 18. I add 18 to both sides. I get 126 is equal to 9x. Divide by 9 on both sides, so x is equal to 14. All right, x is equal to 14. Remember, if you know it, mark it. So I want you to try 12, 14, 16, and 18. Pause the video, try 12, 14, 16, and 18. So for number 12, you need to solve for x. So we add up all of our exterior angles. Because they're exterior, you're going to get them equal to 360 for their sum. So you should have 29x plus 12 equals 360. When you solve that, you end up with an x equals 12. For an exterior angle for a regular octagon, you have 8 sides and 8 angles. If it's exterior, that means they all add to make 360. If they're regular, all the sides and all the angles are congruent. So 360 divided by 8 gets you 45 degrees. For number 16, you are looking at interior angles. Well, the sum of the interior angles is 180 times n minus 2. So you know that each of the angles is 150 degrees. You're looking for the number of sides. So 150 times n, because that's your how many sides is your n, equals 180n minus 360. I distributed that 180, and then I subtracted 180n from both sides, so I got negative 360 equals negative 30n. When you divide both sides by negative 30, n equals 12. So we would call this a dodecagon. For number 18, you are solving for x, but now you're given exterior angles. Their sum is 360. So when they add my 3 angles together, I get 360 equals 24x minus 26. Add 26 to both sides, then divide both sides by 24, and you should get 16.1 equals x. You might have rounded a little differently than I did, but 16.1 equals x. Please email me if you have questions. On the back side of this page is more practice just for you. So try it out. Email me if you have questions. The skills practice is posted to Big Ideas.